Okay, now let's talk about horizontal and vertical reflection. So basically, what this means is reflecting the graph across the x and the y axes. So when there's a reflection in the x-axis, like this, what that would mean would be like y is equal to negative f of x, or it's just like some function. So what the reflection would do is it would make, say, this point 0, 3 into 0, negative 3. Basically, all the y values become negative. So this point, like right here, would now be reflected over the axes. And then this would now be up here. And the function would basically look something like this. The points that don't get reflected, such as this one right here, where like the intercept is 3, 0, are known as an invariant point. So that's what happens when there's a reflection in the x-axis, or it's like negative f of x or whatever. But now let's think about what would happen if it's a reflection in the y-axis. So it's f of negative x. So this would mean that all of the x values get flipped. So this would now look like this. Oops. So it's a reflection basically across the y-axis, f of negative x. So the negative x would deal with all of the x values. So if, for example, if this point here was 1, 1, on the reflected graph, it would be negative 1, 1. And if it was like 2, 4, it would now be negative 2, 4. Okay, great. So let's try this. The point 2, 3 lies on the graph of f of x. So what would happen to the point if we now have y is equal to negative f of x? Well, we know the negative means that this is a reflection, like this was the original function, and that would be the new function. I'll do it in blue. So it's going to be like flipped over and a reflection in the x-axis. So it would be 2, plus 3 now. And then if it was y is equal to f of negative x, well, that's going to be a reflection across the y-axis, and that's just going to change the x value. So it would become like minus 2, negative 3. And then y is equal to negative f of negative x would mean that there's a reflection in the x and the y axes. So both the x and the y would change sign. So it would become y, or the point would become negative 2, 3. Okay, so this one would be like if we had a function like that, gets reflected to that. And this one would be like if we had, say, a function over here, it gets reflected to a graph like that and flipped over to ultimately end up there. Okay, now let's try this. So I'll give you a second to try it, but in this one, basically we have a function, g of x, and then we gotta write the equation after a reflection in the x-axis and the y-axis. So in the x-axis, we would go like this, and I'll do it in white. Negative y equals g of x, right? So basically we're gonna solve for y, and we're gonna divide the whole thing by a negative 1, because we know g of x is equal to negative 2 x to the 3 plus x squared minus 5x minus 3. So we would divide both sides by minus 1. And we distribute a negative in. So now it'd become plus 2x to the 3 minus x squared plus 5x plus 3. Okay, and then let's see what would happen if it's a reflection in the y-axis. So in that case, it's going to be y is equal to g of negative x. So now we would take y and make it equal to like negative 2 times negative x to the 3 plus negative x squared, negative 5 times negative x minus 3. So basically wherever you see an x, replace it with a negative x. So then that's going to become y is equal to 2x to the 3 plus x squared plus 5x minus 3.